Assalamu alaikum, this is Khurram Shazad from Garrison Academy Senior Campus, Kushamala Kent. I welcome you all to FBISE online sport program. I'm here with the fifth lecture of the second week on the topic of process management. In this lecture, we will first revise the last lecture on the topic of basic functions of an operating system. Then we will discuss the process in detail. Now we will go to the detail of what is a process. Then we will discuss what are different states of a process, how a process is created, how a process is terminated, and what are the other states of a process. Then we will discuss the process main and alternative flow. Then we'll make a quick summary, and that will be our today's lecture. So let's get started by the last lecture. In last lecture we have discussed the basic function of an operating system. The basic function of any kind of operating system, for example, it is an embedded operating system, it is a mobile operating system, or it is a handheld device operating system. All the functions are relevantly are almost same in any terms. The first function is process management. Process management means the management of all the running or waiting processes in an operating system. Then we have discussed that memory management is the important factor of any operating system. It must be managed because every computer have a limited amount of memory. To make a computer running fast and smoothly, we have to manage the memory. We have to allot a memory for the new executing program and free the memory of exited program. Then we have discussed the file management. File management means the management of our folders and files. This is the vital requirement of our daily life. In our daily life we are only deal with the creating files, managing file, copying file, moving file from one place to another place. Then we have discussed the device management. Device management is the topic not in your book, but device management is actually the process of managing all the devices attached to a computer and for use. For example, in your computer there may be many devices connected with your system. For example, a printer attached to your computer should be managed, a laptop attached to your computer, a mobile phone attached by using data cable, or any kind of device which is attached to the computer must be shown in the computer system and should be managed and communicated by the operating system. Then we have discussed about the security. Security is the essential part of any operating system. Security means protecting our system from the unauthorized use by using a password or a biometric system or a face lock or any kind of lock. And the other factor of the security is protecting our system from the viruses using a firewall or using a built-in antivirus like Windows Defender in the Windows 10 or any other kind of antivirus or antivirus measurements. Then job accounting, not in the book, but job accounting means the queuing process of any task running or waiting to be executed. Then secondary storage management means the management of the hard disk. Hard disk means the space management of the space available in the hard disk and management of the space occupied by the program in a hard disk. And when we have to copy a new file into our hard disk, it should create some space, it should manage the space accordingly to make the file properly copy to that system. Process management is already discussed. Then network management is the essential part of nowadays. Any computer which is not connected with the internet is considered a very backyard or very conservative system. Now internet is our vital requirement of our daily life. Without internet we can do nothing by using computer, so it is a very vital requirement. An operating system must have the capabilities of network to make sure it is connected with the internet and the other computers which requires to be connected. Then coordination between the other softwares. The operating system must have, this is also not in your book, but this is a task of operating system. The coordination between other softwares means that the operating system must have a knowledge or a wisdom of communicating with other devices. For example, when we attach our mobile phone with a data cable with our computer, the mobile phone have another kind of operating system and our computer have another kind of communication system, but these two communicating system, these two operating system communicate with each other and allow us to copy some file from the computer to the mobile device. This means that these two software, these are the system software, are called operating system, have the ability to communicate between each other, so the file may be copied, and it may also be available for the other user. The operating system must provide some functions to the other user that use the computer system on a network or the remote distance or on one system. Now let's get start our today's topic. Our today's topic is process management. So first of all, we have to understand what is a process. A process is a program in execution, we have discussed already. Now go to in detail. For example, when we write a program in C, a C++, C, a C++ or the language which will be used for coding purpose, we have already coded these languages in the 10th class. Now we will go in detail the program of C. When you write a program, it is simply a text file. The compiler, it is simply a text file, but when you compile that file, it creates a binary file or an XII file or an executable file for the computer to run on that system. This file is called binary code. The compiler creates a binary code, the original code and the binary code. Binary code means the code understandable by the computer, and the original code which is understandable by the humans. The original code is in the high language because it is in the English like syntax, and the binary code is in binary and understandable only by the computer system. Both are the programs, but computer can only execute the binary code or the executable code. When we actually run the binary code, it becomes a process. So we have understood that a process is the execution of any executable or binary code into our computer. A process is a part of the program under the execution that is scheduled and controlled by the operating system. Process may be a part of a process. A program may have many processes running by itself. So all these processes are called process, and these are scheduled and controlled by the operating system. When a program is loaded in the memory for the execution, this process is called loading. When we load a program, when we double click on a program, it will load into our computer system. It becomes a process. I will make you a quick demo after this slide. I will show you what is a process, how a system creates a process, and what is the difference between the code and the process. A program is an executable code that is stored in the disk as the text file. The program may be a text file, whereas a process is dynamic instance of a program. A program stored in the computer hard disk is simply a text file or a code written in some language, maybe binary language, maybe high level language. But when we double click, when we load it into the main memory, it is a dynamic instance, changeable. Dynamic means changeable instance of a program during execution in the RAM. It represents the basic unit of the work. It uses various resources of the computer such as CPU time, files, input output system, and the memory. A process loaded into the memory have different sections. Different sections are the text section, which include the code, data section, the data related to the application, the heap section, and the stack section, which is the upper level concept you will learn later. Now I will show you that how a process actually works. So I will show you what is a process. This is a simple program, you already know that, but this is a simple Google Chrome program. I will show you first all the processes running into my computer system. These are the processes running in my system. I have opened a recorder for recording your lecture. I have an video share, and all these processes which are running in my computer, they are using some amount of CPU. For example, all the processes are using my 29 or 30% dynamic CPU, using some amount of memory and some amount of both of my disk, some amount of network. So it is clear that all the processes use some kind of CPU. For example, this program is using 9% of my CPU, 101 MBs of my memory, and 0.1 MBs per second of my disk storage, and 0.0 MBs internet, because I'm not connected to any kind of network, and this is moderate, very low, or all these. So you are not seeing any kind of Google Chrome process in here because I've not opened Google Chrome yet. So now I will show you where the Google Chrome is actually stored. If I right click and open file location, it will show you that this is the actually Google Chrome software. This is only a text file because it is stored in the C drive, program files, Google Chrome application, in this folder. This is only a simple file. I will show you that by right clicking. If I open it by using my Visual Studio Code, you will show that this is only a binary code which is not displayed by any kind of compiler. And if I forcefully open it into some other program, for example, I can open it in a text editor, you will see the difference. Okay, if I drag and drop this program into this, you will see this is the actually code of Google Chrome. This is in the binary coded and shown very badly. Now this was only of stuff. Now if I double click on this program, it will load into the memory. Now Google Chrome have opened. Now I will show you that this. Now you have seen that in the task manager, in the processes tab, there is another process which is Google Chrome, and a Google process have not only a single process but it have many processes attached with it. For example, if I expand this, Google Chrome have many processes and threads to be run. Now Google Chrome is using actually 0% of the CPU, 207 MBs of memory. So it is very clear that any program which is executed by the computer system have some resources and have a process running, a dynamic process running with it. But when I close this program, the Google Chrome process is already disappeared because our operating system is very smart. Our operating system is smart enough to detect the closed program and make the space available for the other programs. This was the process. Now we will discuss some other concept about the process. This is the process. Okay, now the process have different states, various states of a process. A process may have a new state. When I double click on Google Chrome, because it was a simple application that does not require any kind of other resources, it becomes ready and then it have a running state. But all the program are not of that kind. When we click on a process, it will request the operating system to be ready. When the operating system admit that process to be executed or allow this process to be executed, then it will wait in the RAM. For its term, because the computer cannot start all the processes at a time. So all the processes are running turn by turn because we have a single process which process all these tasks. So it have to wait in the RAM in the ready state. When the process is ready to be executed, then when the turn comes for it, then it will dispatch, it will send to the processor, then it will be called running state. I will show you some other example of processes state. I will minimize. I will show you that our computer have many services already running in it. These are the processes which the computer have already run in the background. All the processes which are in the running state are actually executing in the system. All the processes have no state are actually waiting for their turn. So every process have some states. First state is new. When we create a process, then it will wait, it will be loaded into when this operating system admit or allow this process to be executed, then it will admit it and wait as a ready process to be executed in the RAM device. Then when we dispatch this process into the CPU or the processor, then it will be in running state, and when we have completed all the tasks of that process, or a process is completed its execution, it will be safely terminated. These processes was a normal flow. Process will be created, then it will wait for some time, then it will be executed, and then it will be executed. Was a normal flow of a process. A process may have a different flow. For example, a process is running and it is required a CPU. When I have opened MS Word and I have sent a command of printing, but I have not attached any kind of printer, so our running process will again go to the ready state. I have an interrupt because I don't have a printer attached. So what's printing? Nothing. So it will wait until the printer is attached and ready to be printing. So a running process may also be wait again for some resources. And if a process is running and some other program have terminated, means block it, it may go to blocked state, the final state of a process. A process may be in block state. A process will be blocked from the CPU, and then it will wait again into the RAM when an operating system will unblock it. When a running process is blocked, it will be in block state and sent again after unlocking into the ready state. These are the 5 states of any process. Now I will discuss one by one all these states. First one is the new state. This is the first state of a process when it is created any new operation or service that is requested by the program for the execution by the process is known as the new state of a process. New state means when we double click on a program, it will make some operation and gather some services available to be run, is called a running state. This one is the running state, the new state. When it will be admitted, then it will become a ready state. Now a process is said to be in ready state when it is ready for the execution. It have gathered all the resources required to be run. Then it will be called a ready state process, which is ready for the execution but waiting to be assigned to the processes by the operating system. But processor cannot run all the processes all the time, so it have to wait until its turn. So this is called a running state process. Next one, when the ready state process is dispatched. Dispatch means sent or passed to the processor. It will be called said to be running state when it is being executed by the process. When the process is executing some process, these processes are called the running state process. This is the actual state which requires by any operating system or any program. Whenever we see any program running into our computer, this program or process is in running state, so we may see this kind of process. Next one is the blocked state or waiting state. When a running state may be blocked by a program, a process is blocked or waiting state when it not under execution. It is waiting for a resource to become available. For example, I have told you the example of the printer. When I have sent a command of printing, but the printer is not available, so the printing process will wait until the printer is made available. So it may wait again for the resource to be available. Then the final state, if all things have gone right, then our process have completed all the tasks which we have to complete, then it will be exit. When we click on exit, the process is in terminated state when it completes its execution. Now I will make you a quick summary of all these states. First of all, when we click on a program, it will be a new process. The process will be in state of new. When our operating system admit that process to be run, it will wait in the RAM and it will call a ready state, and when this process is dispatched to the process, it will be called a running state process. And if there is an interrupt, there may be a program which have interrupted, there may be some kind of resource required the process to be available before the execution, then it will wait again in the ready, and when the resource is available, then it again dispatched to the process, and then it will be again in the running state. But if the running state process is blocked by a program or a resource, then it will be in a blocked state process. And a blocked state process, when we unlock or unblock this process, it will be wait again in the ready queue, then it will again dispatch to the processor, and it will be again in running state, and when it have completed everything, it will be exited, and it is called the terminated states, and it will be disappeared. This is our today's lecture. If you have any question, you may ask in the group, and feel free to ask any kind of question, and make sure that your attendance is good. Only few students are taking the lecture, so this is very shameful. You will go backward in this way if you are not make sure that you are attending the lecture. So thanks for today's lecture. Make sure you have properly understand the lecture. Make sure by listening or watching this video is a continuous. You have to pause the video and read the text again and again to get clear, and you also have to read these concepts into the book, so you may get 100% clearance of this lecture. Thank you very much.